Alright, so I am making this with a flip cam, and so the quality is not very good. But this is the EOC Week 1 packet that you received on Monday. So now I'm going to take you through, and you can see it's already kind of blurry. So I'm going to zoom in here just a little bit. Still not great quality, but here we go. You had to simplify this expression, so I just rewrote it here. Square root of 1 over 8. And that can be rewritten with a square root separating the numerator and the denominator, which is what I did. From here, I look at this, the square root of 1, pretty easy, that's 1. But the square root of 8 is not a perfect square, so then I break it down into factors of 8. 4 times 2 are the factors for 8. And I chose these versus 1 times 8 because 4 is a perfect square, and it's larger than 1 times 8, which 1 being the perfect square. So I'm looking at this thinking, square root of 4 is 2, so I take that out. And then the square root of 2 is not a perfect square, so I just place that back in the radical. Now the rule states, this is where I get here. But the rule is you cannot leave a radical in the denominator. It's not completely simplified. So in order to get rid of that radical in the denominator, the only way to do it is to multiply it times itself. So when I do that to the denominator, though, I also have to do it to the numerator. So that's also that same rule that we've been talking about. When you have the same thing on top and bottom, it's also the same thing as just multiplying this fraction times 1. So now in my numerator, I have 1 times the square root of 2, which is square root of 2. And then I also have this that I've got to multiply in the denominator. Well, square root of 2 times square root of 2 is just 2. And then the 2 that's already on the outside, so 2 times the 2 here gives us that new denominator of 4. So this would be your final answer, which was C. Alright, moving to the next question, you had to simplify this expression. Again, I apologize for this quality. I wish it were better, but it's not. Okay, so we also had to find the restrictions, which are those excluded values. So I took this and I factored it into this here, x plus 12, x minus 1, over x plus 2 times x minus 1. And I'm going to, before I start canceling things, you always want to find your restrictions from the original denominator. So I'm going to take these two parts, these two factors here from the denominator and set them both equal to 0 to find my restrictions. So x cannot equal negative 2 and 1. Those are the two restrictions. Alright, with that in mind, I'm now going to simplify it so I can cross out the x minus 1's, and I'm left with just x plus 12 over x plus 2. And the answer for that one was also C. Okay, moving on to the next one. Okay, so on this one here, it was actually it is number 3, okay. It's asking for the domain, so you have to remember that the domain are the x coordinates. And when you're looking at this domain, they're wanting us to write it as a set. So if anything repeats, you only write it once. So with that one little helpful hint there in mind, the answer on this one was B. Okay, next, number 4, the word problem about Sabrina. She's trying to save money to purchase a laptop. Her starting amount, if you look over here, she already had $100, plus she is going to add an additional, let me bring it over here, $25 each month. So she has the $100 plus her $25 per month. Per month would be X representing the number of months, for a total of, I believe, $600. And you only had to write an equation. Now, the thing is you've got to, you can see I used N, I just picked that, but they did, on our choices over here, they chose, I'm sorry, I used X, they chose N as their variable, which is fine. And they switched these two parts around because of the commutative property. So that is fine as well. A would be the correct answer. Alright, the next one. And this is another one I had starred because we have not taught this yet. Alright, again, blurry. So these all had to be multiplied. And it's saying that x has to be greater than 0 because you can't take the square root of a negative number. Okay, so I just kind of made some notes here. Put everything, so take everything that's under the radical and put it all under one radical, which is what I did. And then I went ahead and I looked at my coefficients and I multiplied them to get 24. And I looked at everything that had the same base and I added those exponents, which gave me 9. That does not look like a 9, but it is. Okay, so now I start doing like I did on that first problem where I think about perfect squares. And I'm wanting to think of factors that give me 24, but I'm hoping to pick something as a perfect square. For instance, 2 and 12 are factors of 24, but 2 is not a perfect square and 12 is not a perfect square. So I don't want to use that. So I chose 4 and 6 because 4 is a perfect square. And then I have x to the 9th power. And to get that, I broke it down to x squared, x squared, x squared, x squared, and then x to the first power. And if you go back and count this up, that's 2, 4, 6, 8, and one more makes it that same 9 exponent that we have there. So now we look for perfect squares underneath here. So square root of 4 is a perfect square, which is 2. I take that out. 6 stays under because it's not a perfect square. Next, the square root of x squared is just x. Same thing again, square root of x squared is just x. Same thing again, we get that x out. Same thing again, we get that x out. Square root of x alone to the first power, it just stays under the radical, which is why that stays there. All I did next is simplify this expression to 2x to the 4th power times the square root of 6x. And that answer, I believe, was B. Okay, the next one is right here. And the main thing I'm going to say about this is just to make sure that when you plug these values in that you use parentheses. You use parentheses. And it seems a little ridiculous when you look at this. It seems like I really don't need parentheses right here. And you're right, you don't. But I think it is helpful right here because a lot of times I see people think about that minus sign representing this negative here, and it's not. When you plug in that value, you do need to understand that that's saying minus a negative. So minus a negative is really that positive there. And you can see again, I use parentheses over here. So I went ahead and multiplied that, and I got the negative 8. Simplified this expression down to 5. Minus a negative 8 is the same thing as saying plus 8, so your answer is 13, which was D. The next question was just asking for a positive linear relationship, and of those choices there, the only one that appeared to be going the closest to a line would be D. This one's positive, but it's more of a quadratic. All right, on this one, we've had a couple like this in our bell work recently, and I believe the question is asking for what's the rate of change. You have to remember that rate of change is the same thing as slope. So that right there means slope. So you're already given this equation here, so I just rewrote it larger. And I'm just showing you how it's written in that same linear equation format, that y equals mx plus b form. So whatever's in front of that x, which is in this case the variable that represents x is t here, but 20 is what's representing the slope. And slope, again, I wrote that, is the same thing as the rate of change. So when it's asking what's the rate of change, it's that 20, and it just means that it's 20 feet per second. So D was the answer on that. Okay, the next one is again you substituting values in, and you can just see I went through here substituting it in using parentheses. So within this first set of the parentheses, 2 negatives here make it a positive. Simplify this again, you get these added together, it's a negative 3. 2 negatives when you multiply gives us that positive 15. Moving on here, this is a minus 6, which is a negative 6 times negative 1, which gives us that plus 6, which you can see I carried throughout. Here we have a positive times a negative, which gives us negative 16, which I wrote as a minus 16, and I carried that throughout. So then we have 15 plus 6 minus, which is 21, minus the 16, which we get 5. I think the answer on that one is B. Okay, next we have this one, which is asking for the distance between, and if they give you the formula as they did here, which is nice, you won't have to refer back to the reference page. Okay, so I just plugged this in, and the formula, if you recall, is the x minus x squared plus y minus y squared. So I just made sure that I used x and y and this x and y. So when I set this up, I said 2 minus negative 3 squared plus negative 5 minus the positive 7 squared. So now again, these two negatives make a positive here, which gives me 5 squared. This is negative 5 minus 7, which is negative 12. Negative 12 squared is 144. Add those together. Square root of 169 is 13, which is D. Alright, this next one, I don't think the shading appeared for y'all, but I think the shading, it just slightly did. So if you want to color one in, you should color this part in. And so we're going to select the answer that goes with this. First of all, you need to note that both of these lines are solid already, so that means it's going to either be a greater than equal to or a less than equal to. Those two inequalities will produce a solid line. Now, I would look to see where this first one is crossing right there on the y-axis, which is at 4, so I'm looking for a y-intercept of 4, and it has a slope that's negative, down 2 over 1. So this first equation right here has negative 2x plus 4. And then we'll figure out the inequality with that in just a second. This one, this line here is touching on the y-axis at positive 1, and it goes up 1 over 1. So if I were going to write an equation for this one, I would write x plus 1. So that's just 1x plus 1. Alright, so now I'm going to come down here, and you'll notice that I think most of them all had that. So then you're looking to see which inequalities match up. Now, I chose A, but if you look, they're both a greater than equal to, greater than equal to. So let me talk to you about that. If I go back up here, this line here, if I'm saying that this is greater than or equal to, remember the y values that I pick have to be greater than or equal to this equation. So if I start here, where are my y values going to be greater? Would I move up or down the axis? And you'd move up to where those are greater. So that means you're moving this direction. Now, if I'm here, again, I'm trying to move, based on the answer that I chose, it's greater than as well. So that means I need to move up. Well, the only place that they're going to overlap is going to be in this section right here. So the answer to this, as you can already see, was A. Alright, the next one is very similar to one we've already done. It asks, I believe it asks for which equation? Yeah, the equation that can be used for this scenario. So I'll look through it, and you've already got it right there in front of you. So this is your starting point, your starting amount, 100 cubic feet. And then it changes at 50 cubic feet per minute. That's your rate of change, which is also your slope. So you have your starting amount, which in our case, when we talk about this and in the equation, that's like your y-intercept. And then your rate of change is your slope. So you have that 50x plus 100. And then it equals the total amount that we want, which is 400. So the answer for that would be B. Alright, so here we have a table. This one's on probability. This one, we have this table of data based on the experiment that they did. So we have to use this. This is called experimental probability. So we use these results to determine the probability. for whatever scenario they're going to ask us about. So in this particular one, they want to know what's the possibility that somebody will order. The very next customer will order bread or key lime. So I look at all this over here and I see that they surveyed, first of all, 120 customers. So looking at this totals 120. So I go over here, bread pudding, we have 19. So 19 people out of 120 chose that. And then our other options, key lime, that we're wanting to know about, that's going to be 14 out of 120. So when I look at this, I'm going to say 19 out of 120 plus my 14 over 120 equals the 33 over 120. So there's the next person that walks through, there's a chance, 33 out of 120, that fraction there represents the probability that they will order one of those two desserts, which then simplifies to 11 over 40, which is C. This is yet another problem where you take values and you substitute them in. So this is now, I think, the third one like that. You can see this is a big deal. This is a big concept in algebra, making sure you can plug values in correctly. So you take them, plug them in, use parentheses again, square, you get 1, square, you get 4. There's nothing to do with this, you just bring it down. Then work your way from left to right. Think about order of operations as you work through any of these. 1 plus 4, you get the 5. 5 minus 3 is 2. And this answer is C. Alright, on the next page, it's another one of those that y'all love with the figures and trying to figure the pattern. Now, here's what I would do. Test your options. When I say test your options, that means I'm going to take figure 1, just the number 1, and I'm going to plug that into each one of these and see which one's going to give me the number of squares that are in this figure. So for this particular figure, there are 10 squares. So I want to know when I plug 1 in over here, which one's going to give me the result of 10. Then when I take figure 2, plug the number 2 in over here, which one's going to give me the answer of how many squares we have here. Same thing when you plug in figure 3 into each one of these. It has to work for all figures all the way across for it to represent a rule. Now, the other thing to do is try to identify the pattern. And I'm going to leave this here for just a second and see if you can just identify what's going on here. It might require more explanation within class, but here are the actual steps that go with it. So figure 1 is 10 squares, 2 has 14, figure 3 has 18, and figure 4 has 22. So then I started to see, okay, in figure 1, I have 4 on the bottom and 4 on top, so that's that 4 times 2, plus the 2 extras on the side. That's this one right here and this one right here. Well, then I noticed on the next one it's 5 across the top and 5 across the bottom, so that's 5 times 2. And then there are the 2 additional ones on each side, which make it a total of 4. And then I continued it from there. Now from this, I tried to then identify a pattern. And this is where it gets tricky. Some people can see it and some people can't. But this right here says 2n plus 6. That's what's going to work each time to get that first number. 2n, remember, n is representing the figure number. So first figure, second figure, 10th figure. But this 2n is representing those extra squares that are on the left and right side. So then I just simplified it by combining like terms, and you end up with that 4n plus 6. To me, this second step is extremely time consuming. I think the first one is the better way to go. Okay, so the answer on that one was C. On this next one, we look at our x values and see that it's increasing by 1, and then I look at my y values here, which is labeled as f of x, and I see that there's not something consistent. It's plus 3, plus 5, plus 7. But then, if I take it to the next difference, I can see it's a plus 2 and a plus 2. So when I see this, this is called a second difference. And when you get to, when you see that there's the same thing occurring each time on the second difference, what that means is it's going to be a quadratic function. So then I look over here at my options and I'm like, okay, A and B are the only two that are quadratic functions. So at this point, I narrow it down to A and B, and then I test a point. Plug in 1 and see which one's going to give me that next value, which is 2. Plug in 2 and see which one's going to give me 5. Plug in 3, see which one's going to give me 10. Of course, you can see the answer is there. It's A. You really, in this particular problem, don't have to do any of this work other than just testing your options. Take the first X, plug it into each one, and see which one gives you the result that we're looking for. Alright, next one. So this one is asking for you to use the line of best fit to make a prediction. So you're going to use your graphing calculator, and what I'm going to do is I'm actually going to print off the steps because it's very tedious. So I'm going to print those steps off for you and give them to you, and that's what you're going to use to get through this problem, to remind you how to make those predictions correctly in your graphing calculator. Alright, the next one, you have to remember the rules for multiplying scientific notation. And the rule states you take the coefficients here, which are your decimals, and you multiply them. And then you take that 10 to whatever power and 10 to whatever power. Because they have the same base and you're multiplying, you actually add their exponents. So then you end up with 32.76 times 10 to the 6th power. But you have to make sure you read this note. Be sure to write your answer in scientific notation. So remember, this first number here needs to be a number between 1 and 10. Less than 10. So that means this decimal moves to the left one place so that we get a number, 3 point something, that will be between 1 and 10. So when I move this decimal over, that exponent has to change as well. So I move it over and this goes up. So that makes your answer C. Okay, on the next one, I would change them all to decimals. And you're not asked to put them in order. You're asked to see, based on what's given here, which one of these choices is correct. And if you look, once I change them to decimals, I can see that they are in order from least to greatest. So that would take us to A. Alright, on the next one. This one is asking for us to find the equation, or in this terms, it says function, that best represents this scenario. So probably I'd look to find my slope first. So I look here, plus 1, plus 1, plus 1. This is a plus 2.5 each time. And remember, with slope, you always take that y and put it over x. So I take this 2.5 and put it over the 1. So there's my slope, 2.5. Now, that doesn't seem to match anything I have because these are written as fractions. So I need to remember 2.5 is the same thing as 5 over 2. Move back over here and I can see I've got 5 over 2 in either choice A or choice B. So again, I look, now that I've got it narrowed down to 2 choices, I take this and plug it in and test it to see which one's going to give me 8 as my final result. Again, I would recommend, if you feel like this is too many steps for you, you can always take your x values here, plug them in to see if you get the correct y values. Alright, I think we're getting close. So this one is a compound inequality. It's an and compound inequality. So what I'm going to do is I'm going to separate it. I'm going to write this one as one compound inequality right here. Then I'm going to cover up this side and write it over here. And then I just go through the process of working through it. So I subtract 8 from both sides. I do that on both of them. And I end up with -3. And then this right here would be -1. Divide both sides by the -3. And remember the rule. When you divide both sides by negative, this inequality is going to flip. So then you've got 1/3 less than x. And working those same steps, subtract 8, divide by -3, again, this flips, and you've got x is less than or equal to 4. So now, they wrote that all as one answer, but this is it right here. 1/3 is less than x, which is less than or equal to a +4. That matches our solution. Okay, the next one... Oh, here it is. on down. Where am I? Okay, it's just kind of, there we go. So on here we had to distribute first. So that's 2 times 3x, which gives us the 6x. And then we have 2 times 4y, which gives us 8y. There's not anything to distribute here, so I can basically just remove those parentheses for now. Now combine your like terms. 6x plus 5x gives us the 11x. Positive 8y minus 3y gives us positive 5y. I can't put these together because they're not like terms, so your final answer should be B. And I believe we're on the last one. So on this one, again, it's simplify and find the restrictions. So I factor my numerator, x plus 6, x minus 3. I factor the denominator, x plus 6, x plus 5. Remember, we find our restrictions from the denominator as it was originally. So I take these two here, set them both equal to 0, and I can see my restrictions are going to be negative 6 and negative 5. Now, cancel out my like terms, not like terms, I'm sorry, my common factors. And then I'm left with x minus 3 over x plus 5. And this answer matches A. Okay, that's everything from the EOC packet. Hope you got some help from this. Be sure you check out the other videos for extra help on this week's assignments and to get you ready for your retake on Friday. Alright, see y'all. Bye.